Hambini fans, and welcome. In today's video we have another case study or another roast depending on how you want to look at it, and this one's obviously a bit different, not frame this week, but we have a crankset. So this is a Praxis Works M30 called a Zyant. I think it's a Zyant M30 hollow forged. The customer sent this in, and what happened was he was going through bearings left, right and centre. I offered to sort him out with a set of NTM bearings to fit, but there are some little quirks with this system that we have to overcome. And this video is not going to go the way you may think it's going to go. So please bear with me and let's begin with a bit of a history and a diagnosis. So this is the Praxis M30, which I've just said, so I'm repeating myself. Non-drive side on this side, drive side on this side. This drive side is 30mm, the non-drive side is 28mm. It's essentially a larger variation of this, which is GXP by SRAM. So the two systems are very similar. The main difference being this is an aluminium axle and it is slightly larger. The chainring goes on here, and this side has got a power meter built into the crank arm. Now, the customer, what he had was he had repeated bearing failures, and he thought there was a problem with the bearings because they were enduro bearings. Now 80% of any failure analysis or investigation is the history. So the customer's comments were he was getting repeated failures of the bearings in a very short period. These are the enduro bearings that came with this, designed for a BB86 frame. Now, I really wouldn't recommend you run a 30mm axle in a BB86 frame. You are just asking for a problem. But nonetheless, some people have no choice. They've got these expensive power meters and they have to do something with them. So these bearings are instantly overloaded the moment you try and pedal. You are trying to effectively overcome a Shimano setup where they try to exclude you from using a 30mm axle. These bearings that the customer sent me, now to the touch, they are a bit gritty, which indicates an overload situation. So they need checking. The other thing I did was, if you just look at this, you've got the 30mm running track. On that side, it's highly polished. On that side, you've got this huge mark where the anodizing hasn't been peeled off or taken off. That in itself is a big red flag and suggests there is something bent or running eccentrically. So I went and DTI checked the whole of this axle. In order to do that, you need to stick it in a lathe with a 4-jaw chuck. I could show you that, but it would be taking so long that you're better off watching one of those Handy Tom videos, The Machinist, and he'll explain to you how that works. But nonetheless, I measured this, and this landing is not round. This one, on the other hand, is perfect. So there is either misalignment or a problem with the bearing. So first thing I did was ruled out the crank. Now I don't have a BB86 bike frame, so I made a dummy BB86 bottom bracket out of this block of metal. It's perfectly aligned and it takes these bearings. If they were standard size bearings, I could test them in fairly normal ways, but they have non-standard sizes. They're not universally 30mm. So I've made this bottom bracket, and then we can do a little check, and I will show you how that happens now. So what I've done here is I've pushed one of the bearings, and this is only really to show you what I do, pushed one of the bearings into my dummy bottom bracket holder. This isn't a perfect test because there's a few inconsistencies that you can get, but I'm just showing you this for demonstration. So I've put the DTI on here, and it's measuring on the inner race, and what we can do is we can turn this on, minus 5.75, we will zero it, okay, then turn the bearing. Now it may be difficult to see, so I'm just going to get a mark to put on it. I've put a green mark so you can see me turning the inner race round, and you can see the DTI is registering 0. What? Oh, it's got a bit of run out there, mainly because I'm not turning it very well. There we go. Ah, that's my finger. It's basically 0. 0.01, I wouldn't worry about that, it's just me fanning around. What that tells me is the problem is not really with this bearing, and I've checked these in external situations, couldn't find a problem with the bearings. So what I'm going to do now is I'm going to take you and show you some slides to explain to you what's going on with this in terms of misalignment and how it can destroy your cranks or destroy your frame fairly quickly. Right, so now we come on to the section which we colloquially called roast by PowerPoint. Not death by PowerPoint, but roast by PowerPoint. So in this presentation of slides, I have named it Case Study Praxis M31 Crank Implications of Misalignment. You'll notice there are no swear words on there. I've tried to be swear word friendly to appeal to more masses. By Hambini, aged 5. Now, before we move on to the next slide, one YouTube video viewer called Anthony Williams said I was I just have to move out of the way here, a shite engineer and would become a very good, I would make a very good double glazing salesman, and I had too much hand movement in my videos. Well, Anthony Williams, you know, there's some hand movement for you and some more hand movement for you, so go fuck yourself. History. Now, the history of this this particular job was the cyclist had repeated bearing failures. Bearings, assuming they're decent ones, don't usually fail. There's something else that's going on. He also had some creaking. There's a bit of a red flag there all of a sudden, and the initial intention, just based on email traffic, was to use a modified 6806 NTN bearing set. That'll probably get you a bit further, but it's not a be-all and end-all solution. And he also had problems from day one. Here's his bike. So his bike is a Salsa Warbird. It's carbon fibre and it has a BB86 bottom bracket. If you want to know the intricacies of BB86, then check out my website. There is a diagram on there, but just to give you a quick overview, it is 86.5 millimeters wide. So the distance between the drive side and non-drive side of the bike frame is 86.5 millimeters, and the hole through the middle of it is nominally 41 millimeters. Right, run out and dimensional checks. So let's just hop to the SolidWorks file. And here it is, look. Oh, what a genius. Fucking hell, I wasn't expecting that. Well, I need to give myself a pat on the back. Right, anyway, sorry, I was just having a moment of self-happiness there in a non-sexual way. This is a schematic. It's not the exact M30 crankset that I've just shown you earlier. It's a schematic, but it highlights what's going on. So if we go from the dimensions first, so this area here, which is the non-drive side, that is 28 millimeters nominally, and I recorded 27.99, and then this bit between the two bearing landings is 29.6 millimeters, and that's what I got. It's not, that bit doesn't actually matter too much. The bit under here, which is underneath the drive side bearing, which was the one that had the marks on it, I recorded 29.99 max and 29.94 minimum. So there's a difference there of 0.06, which is quite a lot. And then these things here with the circles around them, they denote roundness. And the roundness around the non-drive side, the fixed drive side, was 0.01. Across the center, which is largely an irrelevant number, I got a deviation of between 0.01 and 0.02. That should be a minus there, but I don't know how when I put the minus into SolidWorks, it went crazy. So I've just left it at 0.01. Really, I could have put 0 and 0.03, but never mind. And then this one, which is again the 30 mil section, that's a deviation from 30 mil. So we had 0.01, which was the, I suppose you could say, the highest recorded, and the lowest was and the maximum was 0.06, and that corresponds to your 2 dimensions there. So on this side, when I use the DTI, it's not round, it's sort of like a squashed circle. Right, let's go back to the PowerPoint. So I've just done the SolidWorks file. Non-drive side was perfectly acceptable. There's nothing really wrong with that one. Drive side's visibly worn and it's dimensionally eccentric. What I've done here is I've done schematics of the 2 bearing arrangements. So on the left we have a Shimano type bearing arrangement, and on the right we have Praxis M30 and SRAM GXP. So this GXP setup is the same as an M30, albeit it's slightly smaller. The Shimano bearing arrangement, which, oh, can I put my collar on? Pointer options, laser pointer. Yeah, so the Shimano bearing arrangement is nominally 24 millimeters, but this setup is also used on 30 millimeter axles by the likes of Rotor, FSA, and a few others. But I'm just highlighting that. So anyway, if we carry on, so on a Shimano crankset there is a preload bolt or collar on the non-drive side, and that is how the bearings are preloaded. On the Praxis slash SRAM setup, the non-drive side bearing, so this one, well, it's not locked there because there's a problem with this, but it's locked, so you can't move it. And the preload is set by a wave washer. Right, so on Shimano, both bearings, so this one and this one, are free to float. I'm saying on Shimano, there's also the 30 millimeter variants that will have the same kind of setup, and the slack is taken up by the preload bolt. So if you are running a Hambini BB or even a split BB, you'll have a bit of float in there because they generally make the axles wider than the worst bicycle frame. So you can tighten the preload up and it'll bring it all together and stop any play. It's a different ball game on the Praxis system because you've got this bearing locked, and this wave washer only preloads the drive side bearing. So that is a completely different system. Now, if you were to go one step further and put the loads on it, on a Shimano bottom bracket, or Shimano axle really, the drive side and the non-drive side bearing are taking load in these directions. So if you are pedaling with the left foot down or the right foot down, the bearing loading is in the same direction, whichever. So the non-drive side bearing loads that way, and the drive side bearing loads that way. Typically, if you are putting your right foot down, the load is actually going through the non-drive side bearing. If you're putting your left foot down, the load is going through the drive side bearing. So it's opposite. Contrast that to the Praxis system. So on the Praxis system, or SRAM GXP, the non-drive side bearing is taking load in both directions. So whether you put your left foot down or your right foot down, that load is going through that one bearing. So the axial movement load. And then this bearing on the other side is purely there to cope with radial load. So on Shimano, both bearings are equally loaded and it can cope with any slight misalignment. And there are a load of patents around this. I don't know why people bother with some of these patents, because I could get around them in like 20 seconds. Obviously Shimano might be after me if I got around one of those in 20 seconds, but I don't really think they'd have a leg to stand on. They're not watertight. The Praxis system, or GXP, you've got the non-drive side bearing is heavily loaded. It's well, how can I put it? You've got the bearing is basically shuffling from left to right. So if I can just bring the ball up, hopefully you can see if it focuses on it near my head. The ball is moving from left to right, whereas on a Shimano setup, the ball is just moved all the way to the left on one side, the non-drive side, and all the way to the right on the other side, the drive side. I'm not sure if I've got that orientation right, but basically it's just fixed. It's fixed in one plane, whereas the other one, you've got it rattling around like crazy. So that's what happens on GXP. It's rattling around. So you've got a lot more friction. It's significantly more friction. It's 20%. Okay, it's 20% of a fairly small number, but that's in the best case scenario. So that's if you've got perfect alignment. If you've got any misalignment, you're fucked. You're completely fucked, because you've got no wiggle room at all. So it is technically inferior, and it purely exists so that they could run well, GXP in a Shimano bottom bracket. Praxis M30, I'm not sure why they did that, but anyway, they have done. The premise is it's, you know, a superior system. In my engineering opinion, it's shite. Right, bearing frequency check. So what this is let me just put this up. Right, first of all, the DTI reading, which I just showed you, had no run out. Okay, there was like 0.01 millimeters, but to all intents and purposes, it was 0. There was, and now if we go to the graph, what we have is, this is after I spun the bearing up and then measured the frequencies. So this one here is fundamental train frequency. So if I get my bearing here, well, I have to start actually at drive frequency. So drive frequency is the speed that I turn the inner race at. So in effect, you could argue that's your cadence. Okay. The fundamental train frequency is the speed that the cage is going round at. Now the cage is going round at a slower speed than the drive frequency or the inner race. The next one is ball spin frequency. So each one of these balls is spinning, and it's spinning at a higher speed than the inner race, because the balls are smaller. So for every, making this up, but that's 2, so that's 11. So for every 1 revolution of these, one of the balls goes round 5 times. Oh, sorry, no, I've done that wrong. So for every 1 revolution of these, the ball goes round almost 4 times. Then we have the ball pass outer race. So if there's a defect on the outer race, every time one of these balls goes past it, it's almost like going through a pothole, and you get a spike from that. And the same deal on the inner race. So if there's a defect on the inner race, every time a ball goes past that, you'll get a spike. Now, if you look at this trend, that's showing a very high ball pass frequency on the outer race. So it indicates a defect on the outer race. And that is consistent with axial overload. Okay. The probable damage mechanism that's occurred here is we've got our fixed locked bearing there on the non-drive side, and we've got the bearing on the drive side which has ground the axle. And the likely reason for that is well, almost guaranteed to be misalignment. I sincerely doubt that Praxis would have let that crankset out of the door with a run out that I've measured, and I would hazard a guess that the frame is out of alignment. Now, it may not actually be that much out of alignment, but you've got the culmination of multiple tolerances that are fucking you over. So you've got M30, and then you've got a BB86 shell, which added together gives you a problem. You would probably be able to get away with it if you had a Shimano crankset. The actual name for this kind of damage mechanism is called under rotation. So under rotation is, let's say the crankset, the inner race is spinning at 100 RPM. Periodically, when it goes out of alignment, the rider is still pedaling at 100 RPM, but this momentarily stops. As it stops, you've got a sliding surface, so the bearing rubs against the crank axle and grinds it down, and that's called under rotation. The bearing is much harder than the crank axle, so it wears the crank axle down. It doesn't even touch the bearing. And then the outcome is this. So this probably isn't all that clear, and I had to fuck around with Bezier curves and all that bollocks, which I don't really understand, but people who use Photoshop really do. The bottom of the crank axle is worn flat, so you've got irregular wear there. And the final conclusion, right? Well, first of all, there's no point using a ground end-to-end bearing because you would not get anywhere. The root cause is likely to be the frame. I'd hazard a guess, I'd put a large sum of money on it that it's the frame. Not proven, so I can't go and say Salsa bikes are a bunch of fucking cunts, because I don't have the data to say that they are at fault. But based on probability, and if I was a betting man, which those of you who regularly watch know I am, I would put some money that there's some misalignment in there. Yeah, it's unlikely to have left the factory from Praxis in Taiwan with that sort of run out. So, you know, just in general, M30 and GXP are really unforgiving if you've got any misalignment. So Shimano axle, because it's not running directly on the bearings and it's steel, you can have that element of under rotation and your crank will be fine. You will wear like the plastic bushes out, so my bottom brackets for Shimano have that, but you won't destroy your really expensive crank axle. So yeah, that's one of the reasons why I don't recommend GXP on any day of the week. Yeah, if you get creaking and this is the cause of it, or misalignment, you really should be stopping. Putting grease in there, all that does is it masks the noise. So you've made the sliding surfaces have less friction, so you can't hear it, but they're still sliding and they're still probably grinding. You really want to get rid of that noise. If you've got a different thing that's creaking, so instead of the axle creaking in the bearing and the bearings creaking in the frame, then that's even worse because it's a hardened bearing in either a softish aluminium or a very soft carbon fiber frame. It'll just wear it to smithereens. And the net result was this chap elected to continue riding with his current bearings and the failures that he was going through. So I think he was going through bearings every 6 weeks, something like that. So he was just having to pay to do that. I explained to him the situation and sent the crank back with no work. And I've just left him at that. Right, so I hope you enjoyed this video. It's not one of, well, I was going to say it's not one of the normal videos, but it kind of is. If you are in the market for a crank, then you've seen what can happen if it goes wrong, especially in a frame that probably has a degree of misalignment. Now, if you did enjoy this video, please whack the like button. If you've got any comments, then use the comment box below. I do read all of your comments. I try and respond to most of them, but regrettably, because of my newfound fame as, well, an engineering porn star, then I can't reply to them all. Please whack subscribe, tell your mates, and you know, keep it hanging. Till next time.